Hey guys, Mike, and this is part 2 of OMO development. So, after part 1, we've pretty much finished all of the basic structure stuff. We have all the game states, the game state managers. Well, there's only one, but that's pretty much it. We have our projects here. We can start making the game. So, the game, I didn't explain in the first video. This is what I pretty much want the game to be like. Okay, so we have the dark background that I made. I'll just fill that up here. Boom. Or I'll fill up a rectangular area here. So here's our phone. It's portrait, so it looks something like this, right? Hold up, let me get out my pen. Where is it? I got a pen tablet here. Oh, there it is, okay. So, I'm going to be using bright orange for this game, all squares. So pretty much, this game is going to be very simple, first of all, and it's, whenever I make games, I want to make games specific to the Android system, which means that I want to utilize the touch screen. I don't want to make games like first-person shooters. I don't even know how they make games. Android games, first-person shooters. How exactly are you going to control that? I really have no idea. Or platformers where you have arrow keys to move. I guess you can draw virtual buttons for that, but I just find that really, really awkward. So when I'm thinking up of Android games, I really want to make games that utilize the input hardware, which is the touchscreen. So, the game that we're going to make is called OMO, and it's pretty much what I want to do is sort of like, okay, so how do I explain this? This is like, everyone knows what Simon Says is, right? That Simon Says game where a bunch of things light up and you have to try to hit the right ones. So pretty much it's like that. So, you have a bunch of these that are lit up and some of them that are not so lit up. Let me change the color to something darker, like this, like that. So pretty much some of these are going to be lit up like this, so these bright ones, so you're going to have to tap those. So what I want is, first of all, for this bright stuff to show up when the game starts. The bright stuff is going to be on the screen for a little while, maybe about 5 seconds. And then they're going to disappear, and then the game will actually let you tap on the grid. And after that, you have to try to remember which ones were lit up and tap those. Once you tap everything that was lit up before, then the game sees that you're done, and you'll get points. So you get plus points for tapping them faster, and you get minus points for tapping the wrong ones. I'll call them tiles. So pretty much that's what I want the game to look like, and this can get very hard very quickly, of course, because I can make grids of any size. Like this is just a 3x3, which is simple. I can make a 6x6. Has 36 different tiles, which is you're gonna have to stretch out your brain capacity for remembering all the lit up tiles for that. So let's go ahead and get started. First off, I'm going to need a grid, right? Let's see, private tile, a 2D array. I'll just call it tiles, pretty much. So we don't have a tile class right now. Oh, by the way, this is in test state. I should probably rename this. So if you go into the class name over here, just click on it, press Shift Alt R, and it'll highlight this thing with a box around it, and then you can rename it to whatever you want and press Enter, and everything gets renamed. Even the class name over here. So everything gets renamed if you press Shift Alt R. So over here, tile, we don't have that, so let's make a new package for that. I'll call this UI, and we'll put the tile class up in here. Before we go with tile, well, first let's import this just to get rid of the error. Okay. Back in UI, I'm going to create a second class called box, and this is going to give us a bunch of other this is pretty much a rectangle. I don't want to use libgdx's rectangle class because that's bottom left corner centered. I want a box, my own rectangle class that's XY centered. So private float X, private float Y, private int width, and private int height. I can make X and Y ints actually. Or I can make these floats. Everything float. That's fine. Okay. So here, this is my box class. XY is the center of the where I want it to be. So if I wanted to put a box at position 100, 100, with a size of 100, 100, then it's gonna start at 0 pretty much. Let's see. Oh wait, this is going to be a base class, so I'm going to need protected instead of private. My bad. Because I'm going to derive off of this. So that's our box class, XY width height. What else? We can make some useful methods like boolean contains, float X, float Y. All this is going to do is tell us whether or not this point XY is inside this box. This is just returns return. Let's see, X is greater than this dot X plus or minus width divided by 2, and X is less than this dot X plus width divided by 2. Same thing with Y, minus height divided by 2, and Y is less than this dot Y plus height divided by 2. If you need an explanation as to why that works, I'll just do it quickly here. So here's our box, XY centered over here. This is XY, and it has width. I'll just use W. Width over here, and height over here. So we want to find out whether or not a point PX or PY is inside here. So let's say it's over here. Then obviously we have to check X minus width divided by 2, which is over here. X plus width divided by 2 is up here. And Y minus width divided by 2 and Y plus height divided by 2. So I'm pretty much checking these two corner areas over here. Well, all the corners actually. Here, I want to check that X, the point X, is between this and this. That's X minus width divided by 2, X plus width divided by 2, and this and this. That's height. Y minus height divided by 2, and Y plus height divided by 2. So that's pretty much that for contains. Now that we have that, we can go back to our tile class and extend box. So our tile is going to inherit all of this stuff, X, Y, width, and height, and this contains method. Okay, so our tile is going to be part of a grid, so it's going to need width, height, whatever. So first off, we need an image for this. Private texture image. I want two different images. Remember what I had before? Oh crap, I just deleted that drawing. I had the grid that was this, and then some of it was like dark and some of it wasn't. So I need two different images. One of them is lit up and one of them is not lit up. Something like that. So two different colors, light ones and dark ones. So I'm going to just put these here, light, I guess, private texture image dark. And it's not importing. Did I spell it right? Oh, it's not texture image, it's texture region. My bad. Okay, there we go. We also gonna need a boolean called selected. and this is going to tell us whether or not this tile is actually lit up. So selected means it's lit up, and I'm going to have to draw using light instead of dark. And our public tile constructor is going to just read in the light and dark. And light is equal to whatever, and whoa, and dark is equal to whatever. Wow. Thanks, Eclipse. Let's just comment these out for now because we can't really do anything with texture regions yet. Hold up. Let me just go over here. Okay, so this is going to be where I put all my resources, like Photoshop them or whatever, paint. So Omo, let's create our light and dark. So our light is going to be 2 pixels. This is just 2 by 2, right? I'll make it bigger so you guys can see. A light orange color. Let's see. I'm just going over here trying to pick out something that looks cool. Light, maybe that. Right? That looks cool. So just 2 by 2. I don't want it to be too huge because I'm going to be, this is an aliased square, so it's going to look crisp on all screen sizes. So I'm just going to save this. So I'm just going to save this over here, and I'm going to save it as PNG so it's not messed up looking. And I'm going to save this as light, and then I have to pick a dark color. So back over here, why did it change? That was weird. So this is going to be darker and less saturated, because every time I pick a darker color I usually saturate it less, so going downwards here. I guess that would do. Well, we can always change it, so I'm going to save this one as dark. Dark.png. Cool. So we got light and dark. Light is just this color, and dark is just this color. So what we're going to do, this is Android, so I'm going to want to use the texture packer every time we add new textures. Well, pretty much these 2 images are going to be the only textures that I'm going to use, because I don't. This is it. This is going to be a simple game, just light and dark color boxes. So I'm going to use a texture packer. Over here, I got the texture packer. If you guys don't have it, let me try to find out where exactly I found it. I think you could just Google it, libgdx texture packer. I think this is the one, GDX texture packer. Yeah, it pretty much looks like this. So just Google it, libgdx texture packer, and grab it, and it's going to help you pack all your textures into a pack, so that into a single texture. Let me move this down here. Okay, so open that up, and we're going to pack the stuff. So over here we got this. This is what it looks like. Well, you already saw the image. So first off, new pack. We'll just call it pack, and set the input directory to the directory that contains all of our images. So I'm just going to go to this OMO directory here, pretty much just click that, open /OMO. Output directory is going to be 1, the parent. Above that, doesn't really matter, just remember where you put the pack, and then just click pack selected, and it should be done. And you should have a pack that looks like that. It's just every single image inside there that is packed into one image. That's what it does. So let's go back to our Android project over here and go into our assets. Here's the Bad Logic logo. from the default. Just get rid of that. We don't need that. And what we're going to do is we're going to add both our pack and pack, both of them pretty much here, pack.pack and pack.png. Yeah, so that's pretty much that. Okay, now that we have these, we want to load them up. I have never used libgdx's asset manager, so I don't really know how that goes. I'm just going to use my own manager. I'm going to create a new package. We're back in our core project, by the way, called handlers, and I'm going to create a class here called content, and this is going to handle all of our resources using hash maps with a string key. And first off, we're going to use a texture atlas for all the packs, because that's pretty much what they are. The packs them into atlases. So public content, the constructor is going to just initialize this to an empty hash map, texture atlas. Ooh, what's going on? What? Okay, my bad. Okay, so that's our content so far. What we want to do is we want two methods. Load atlas using a string, and public void, we want to grab the atlas. Yeah, get atlas using the same key. So this one's simple. It's just atlases dot get and then using the key. What's going on? That's what? String texture atlas. Why is that atlases dot get object key? This is a hash map of type texture atlas. Why is... Oh, my bad. I forgot the return. That was so dumb. Okay, anyway, let's go ahead and load atlases into our hash map over here using the string key. So this is going to be our path. String, this is actually going to be path and key. So what we want to do is we want to do atlases dot put. This is going to put a new texture atlas, new entry into our hash map. First off, we want a key, so we're going to put the key in there, string key. And we want the texture atlas, which is just I forgot how to do this. Gx.graphics? No. New texture atlas? I think yeah, that's fine. New texture atlas, gdx.files.internal using path. Hopefully that works. Okay. Well, we'll see if it works. So let's go back into our OMO. This is our main class, and we're going to create up here a public static content. I'll call it res. So this is visible everywhere. Okay. We're going to do res is equal to new content, and then we're going to load up our pack. Res.loadAtlas. The path to the pack is just nothing. It's pretty much, this is relative to the assets folder. So slash, no, it's just pack.pack, I think. And the key, I'll just call it pack. Hopefully that works. So let's run it. If we get errors, then we know it doesn't work. Okay, it works. Well, let me just test it. I'll call it packs.pack, and that should just give me an error. Yeah. Big errors. File not found. Alright, so this works. Load atlas pack.pack, and we're going to use the key pack. So that's enough for content. Let's go back to our tile. Here, I said we were going to load the light and dark texture regions, so let's go ahead and do that. Now that we have the pack loaded up, we're going to do omo.res.loadAtlas. No, not loadAtlas, getAtlas. We have already loaded it. Get atlas, and the atlas that we want is called pack. and we're going to find the region called light. This find region pretty much gives the name of the image that you use. So light.png, dark.png. So this is going to be called light, and this is going to be called dark. So that's pretty much it. Let's do the same thing for dark, and the region is called dark, of course. Just like that. So that's our tile with the light and dark. We also need a update float_dt if we need it, and a render sprite batch SB. Okay, let me just move this down. So first off, we're going to need to specify the position and size. So we're going to add that all as arguments and just set those. This.x is equal to x, this.y, width, what am I typing? Height is equal to height. Okay. So we're just going to set the box over here. Every time we create a new tile, we have to specify the position and how large it should be. And again, this works because I'm deriving off a box which already has x, y, width, and height. So let's go ahead and try the render. As a test, we're going to just render the light image. So sb.draw, and whenever we draw, it always starts at the bottom left corner. So again, since this is xy centered, I have to draw it at x minus width divided by 2, y minus height divided by 2. So let's try drawing the light texture region. X minus width divided by 2, and y minus height divided by 2. Like that. And let's test out to see if this thing actually works. That's our tile class for now. Back in the play state, we have a 2D array of tiles. Let's go ahead and make something out of it. New tile. Let's make it 4x4 for now, and fill it up. For int row 0, row is less than 4, row plus plus, or in column 0, column is less than 4, column plus plus. I'm using a 2D array here. Some people might want to use just a 1D array, but I don't know, I really don't find that necessary. So double for loop, it just looks simpler for me. Tiles is equal to tiles row column is equal to new tile. Remember, when we create a tile, we have to specify the position and the size. So let's specify the position first. We want this to be a grid, so we're going to lay it out like a grid. Let's say each of them is going to be, let's make the size, put the tile size up here. Let's say they're 50. So what we're going to do is we're going to set the position at column times tile size. I'm just going to move this down. Column times tile size, row times tile size. That's the position. And the size, of course, is just tile size, tile size. That looks awkward. But I'm just trying to fit it into the recording area. So we're just filling up our tile with that. So let's try and actually render this stuff. Render. For int row 0, I can't really use 4, that's hard-coded. Let's change the 4 into something a little better. This is tiles.length. The column is tiles0.length. So, just so I don't have to hard-code 4 into there. Okay, so we have our new tile 2D array. Let's try to render it. We're going to do tiles row column dot render. Hopefully that should work. So let's try running it. Ooh, we're getting errors. Sprite batch must be called begin. Okay, my bad. I totally forgot about the sprite batch. sb.begin and sb.end. And I also forgot about the camera, which is totally important. So let's go back into the state class. Every game state needs to have a camera. Protected. Orthographic camera. Cam. And in the constructor, we're going to create a new orthographic camera. And we're going to set the size. Set to ortho false. And we're going to use omo.width and omo.height. So now our camera is 480 by 800. So, and this is for every game state. Every game state has their own camera. So back in play state, now that play state has its own camera, before we draw anything, we always have to set the camera. sb.set projection matrix cam.combined. Then sb.begin. Then we can draw stuff. Then sb.end. All right. Let's try running it again. And nothing's showing up. Cool. Oh wait, no, there they are. They're over there. I see them, they're little dots. So basically we can't see them because we didn't set the size. So what we're gonna do, instead of all this, we're going to do tile t is equal to new tile. The same thing pretty much. Oops. Column times tile size, row times tile size, tile size, and we're going to do t. Wait, but we already set the size. Oh, my bad. My bad. No. Undo everything. Don't. Whatever I just did there, undo that. So you still have this. Tiles row column is equal to new tile. Whatever. I forgot in the render method to actually use the width and height. So here when we render, we have to do width and height at the end, and that's going to change the size that it's rendered at to the actual width and height. So if we load it up now, we see we got this. Cool. But you can't really see where one element ends and the other one begins, so I'm going to subtract 8 from both of these just so we have a little leeway. There we go. There's our 4x4, but it's down there, so that's going to be a little issue. We can move that up later. So that's going to be the grid for now. Let's first off, I'm going to just center it, and that's going to be the end of this video. I'm going to center the grid at the center, and I'm going to change the size to fit the center. So if I want a 4x4 grid, this is I have to remember that the game is 480 by 800. It's 480 width. That's the important part. So if I want a 4x4, 480 divided by 4, each one of them should be 120 tile size. So tile size should basically be omo.width divided by tiles.length. That's the number of rows. I need number of columns, right? Tile 0.length. That's the tile size. And I'm also going to need a Y offset. I'm just going to put these up here as fields. Int tile size, private, float Y offset, or board offset. So tile size is omo.width divided by tile 0.length, and the board offset is going to be the board height. So this is tile size times tiles.length. That's the height of the board. I also need the height of the game, which is 800. So that's omo.height minus this, I think, and all of that divided by 2, I think. Omo.height. Yeah, that should be fine. And when we create the tiles, we'll just add these to the position. So new tile, XY, width and height, XY, width, height. So the X is now going to add, no, the Y is going to add the board offset. Hopefully that works. Okay, that is not centered on the screen. It's should be, the X should be plus tile size divided by 2. There we go, but it's still not centered Y off screen. It's a little bit down to the bottom here. I think this is also should be plus tile size divided by 2. Cool. So there's our grid. That's a 4x4. Let's see if we change it to a 3x3. It should just automatically change everything, size and position. Awesome. Let's try a 6x6. Awesome. That's so cool. Anyway, that's gonna start us off for now. That's gonna be the end of this video. In the next video, we're going to be able to select the tiles using the selected boolean over here, and that means we're going to be using the light and dark. So that's going to be it for this video. Thanks for watching.